This video is over the Pythagorean theorem. We kind of ran a little bit short on time in some of my classes this week, so I wanted to make sure to have a video to share with you guys in case you need a little bit of review. So I'm going to go quickly through these notes, and they'll be available in hard copy form if anybody wants these when they come to school. So some of you guys got them, but we all worked with Cheez-Its this week, and we all made a triangle that had Cheez-It side lengths of 3, 4, and 5. So I asked you guys to square those amounts, and literally you made squares out of those Cheez-Its. And when you did, we talked about the relationship of the numbers 9, 16, and 25. And what we ended up showing was that 9 plus 16 equals 25. And that is showing the Pythagorean theorem. So if you take those two shorter side lengths, those are called the legs. So A is called a leg, B is called a leg. They will equal, when you square those side lengths, they will equal, when they add together, the same amount of squares as the longest side when it is squared. And that thing is called the hypotenuse. If you're one of those people like me who has to sound things out in a funky way when they spell them, just put hypo-10-use, or say that in your head, hypo-10-use, and that's hypotenuse. So again, the short side squared plus the next short side squared, if you combine those, that's going to equal the long side squared, your hypotenuse squared. And in the problems that we work on, most of the time, they're going to give you 2 out of 3 things, or somehow you will be able to figure out 2 or 3 things, and you just need to solve for that missing length. So you're either going to be missing a leg length or the hypotenuse. So you're either going to miss an A or a B or a C. So let's take a look at some of the examples. So on this example, no matter what the distance is, I think this one in the book is like kilometers. So don't worry about that. Just remember that these side lengths, just like the Cheez-Its, if I were to make a square of 20 by 20 Cheez-Its and combine that with another square of 21 by 21 Cheez-Its, that's going to add up to this third side length when it is squared. So I like to write the Pythagorean theorem and plug in the 2 pieces of information that I do know, and then solve for that missing one. In this case, it's C. So 20 squared is not 20 times 2, it's 20 times itself twice. So that's 400. And then 21 squared is 441. And together, if I combine those, again, think back to the Cheez-Its, 9 plus 16 was 25 when we were squaring them all. So when I add up these, this is 841 equals C squared. And I'm going to get a different color of a marker to show you that when we have C squared or something squared, to get just plain C, I'm going to take the square root of that. And if I square and square root a number, I'm just going to get plain C. That's what I'm going for. The square root of 841, if I put that in my calculator and I press that magical radical symbol, okay, it's going to be 29. So C equals 29. I just found the length of that third longest missing side. Same thing for this one. Don't let the decimals throw you off. I'm missing 2 legs, 7.2, 9.6. Those are my 2 legs. I must square them and add them, just like the Cheez-Its. Okay, we did the 9 and the 16, and we're going to do the same idea on this one. Okay, 7.2 squared is just 7.2 times itself twice, 51.84. 9.6 squared is 92.16. And if I keep that on my calculator, I can add it back to the 51.84 pretty quickly and get 144 there. So 144, and I know that, I recognize that pretty quickly as a perfect square, but I'm a math teacher, so maybe you don't, but hopefully you will. I want to find the square root to get C all on its own, and I think you guys probably know that C equals 12. So the missing length, my hypotenuse, is 12 on that problem. Now you could also be missing a leg. So missing a leg is a little bit different. We know one leg, but we don't know the other, and we do know the hypotenuse. The hypotenuse is always across from that perfect right angle. That's because all of this applies to only right triangles, okay? So if I know that this is 10.6, and I know that one of my legs, honestly, it doesn't matter which leg you're talking about, one of my legs is going to be 5.6. They actually did us a favor and labeled this A. So A squared plus B squared equals C squared. Okay. Remember, you have to square before you add. A lot of students would say, oh, 5. 5 plus 5.6 equals 10.6, but you have to square it. That changes the value. Talking 2-dimensional, and that changes things. So 5.6 squared, I'm just going to do 5.6 times itself twice. That's 31.36. 10.6 squared is going to be 112.36. Still have my a squared because I need to solve for a. Now what I need to do is say, okay, I need to solve for a, so I want to get it all alone. If I'm adding something to that, okay, remember we talked about building our balance. Okay, if I've cleaned up the left and the right as much as possible, I'm going to undo the things that are happening to my variable. Okay, doing opposites. Adding and subtracting are opposites. So now I just have a squared equals whatever 112.36 minus 31.36 is. That's 81. A squared equals 81. Okay, you would have just done 112.36 minus 31.36. And when it equals 81, again, one more step to solve for it is we're going to find the square roots of both sides so that we just get a only. And that distance is 9. Okay. I'm just double checking my math. Yeah, it was 81. Okay, last but not least, we've got this one. We know our hypotenuse across from that perfect right angle is 15. So I'm going to plug in that. I don't know B, or one of my legs, and then 9 is the other side. Square them, add them, they will equal the other distance squared. Don't just skip past the squaring. So this is 81 plus B squared. 15 squared is 225. Take away the 81 to get my B all on its own. Okay, B squared equals 144. And 144, I'm just double checking because I want to make sure I get my video right. It is 144. And as usual, like the others, we've done find the square roots that B alone will equal that missing side length, and that is 12. Okay, so you can find those out. That's actually number 9. Okay, and that is how you're going to be solving these problems with either missing leg or hypotenuse. So you can thank Pythagoras if you ever have any right triangles that you need to find a missing side length for. See you guys.